Today we are going to obtain the reduction formula of the integration product of the two function x to the power n and e to the power ax with respect to dx. The question is this. So applying integration by part formula, we have the integration by part formula. Both function, the first function and the second function are the function of x. U and v both are function of x. Then integration by part formula is the first function u multiplied by integration of second function minus integration sign derivative of first function, integration of second function, and dx. This dx is for this integration sign. By applying this by part formula to our question product of two function, we get this: the first function multiplied by integration of second function minus integration of the product of two function, derivative of first function and integration of second function. Again dx is for this integration sign. We get the first function is u and integration of second function, we know e to the power ax, integration of e to the power ax is e to the power ax divided by a minus integration of derivative of x to the power is n x to the power n minus 1, and integration of e to the power ax is e to the power ax by a, and the dx is dx. We get x to the power n e to the power ax by a minus the constant n divided by a comes out of the integral sign, and the remaining integration is x to the power n minus 1 e to the power ax dx. For the reduction formula, we have to compare this integral with question. We denote x to the power n e to the power ax dx is equal to in. So this integral x to the power n minus 1 e to the power ax dx is the degree of x is reduced, so we can denote this integration as in minus 1. The relationship between x to the power n multiplied by exponential function integration and another integration x to the power n minus 1 e to the power ax dx is the required reduction formula. So the reduction formula of x to the power n e to the power x dx is x to the power n e to the power x by a minus n by a times n minus 1. This represent this equation as equation 1. Now to evaluate the integration application of this reduction formula, evaluate the integration of x3 e to the power x when taking n is equal to 3. From equation 1 we get the value of I3 as this. By putting n is equal to 3, we get x to the power 3 e to the power ax by a minus n by a become 3 by a, in minus 1 become I2. This is the reduction formula of I3 with I2. Again, to obtain the value of I2, put n is equal to 2 in equation 1. So I2 is equal to x square e to the power ax by a minus 2 by a, 2 minus 1 I1. Again, for the value of I1, put n is equal to 1 in equation 1. It gives x to the power 1 e to the power x by a minus n by a becomes 1 by a, and n minus 1 become I0. We have to stop to applying the reduction formula because this reduction formula is applicable for the positive n greater than or equal to 0. So the value of I0 is computed as by putting n is equal to 0 in reduction formula first. We get I0 is equal to x power 0 e to the power ax dx, and x to the power 0 is equal to 1. So integration of e to the power ax dx is e to the power ax by a. Now the required value of I3 become, after substituting the value of I0, this is the final answer.